Recording in progress. All right. So welcome to April. And this is, of course, the class website. And this is the syllabus. And today is April 7th, during which we will have a review. That means that you all get to ask me questions, and I do my best to answer them. That's the ideal way that this proceeds. So lay it on me. What have you got? JJ, right? Every time a weekend goes by, I like lose a little bit of my memory of names. So, okay. Yes. Okay. Let's let's take a look at that. So, okay, so this is a simple code which causes an exception to occur, right? So I have a test method, I have a string x equal null, I try to get a caret called caret on there, it gets a null pointer exception, and my code dies and leaves a stack trace, right? So if I do this, you can see my code die and you can see the stack trace there. Okay, and that's basically how it works. But that's just the beginning of the story. That's just the beginning of the story. We have so we have the ability to do a try and a catch and capture that exception. So here I have the same code, but I have a catch null pointer exception. And if I run this code, nothing will happen. I won't know that I had a null pointer exception. Nothing will print to the screen. If I, on the other hand, uncomment this line here, this will print the same stack trace to this screen that I always see, and it won't be obvious that I caught the exception. So, but I can do anything I want inside this catch block, and my code will proceed as, you know, the idea is if I catch something and I do something in there that I believe I have recovered from the error and the code can proceed. If I don't do something in there, then the code knows it's supposed to stop running. There is a hierarchy to exceptions, which you can almost see. You know, why is it so hard to get user interfaces right? Why do they make me do this? Why do they make me sit there and play this game where I have to get the one pixel thing to grab and slide? I mean, anyway, so we have a hierarchy to exceptions. We have the base class of all exceptions is throwable, right? And we have two main subclasses of throwable, and that is exception, which is checked, and error, which is unchecked. And then we have an additional subclass of exception called runtime exception, which is unchecked, right? So if you're creating your own exception types, whether it's checked or not is optional. For errors, the notion is that they are unchecked because you aren't supposed to. Chances are, if you're getting an error, your code is supposed to die. The reason that runtime exception extends exception instead of something else is that way, if you try to catch just exception, you will catch all the things that theoretically you are allowed to catch, right? You won't catch an error, but you will catch anything else. And then anything else can include checked and unchecked exceptions. Does that all make sense? Anybody? Yes. Just you given me a minute, I would have done it, I think. Okay. So checked, yeah, so I didn't quite get to that. So checked, if it's checked, that means that if an exception gets thrown in the body of a method, then either that method has to have a throws clause on its declaration, or you have to put a try catch around it, one of those two. So you either have to take responsibility for the exception or you have to delegate it to someone else, right? So that's what checked exception means. It means you must somehow account for the fact that an exception might get thrown. Michael.
And so how would you like is it like a trial and error figuring out like if the exceptions will happen, or can you like predict like
Well, so the compiler will figure out if the exceptions can happen if they are checked exceptions. As far as things like runtime error, I mean, null pointer exception and array index out of bounds exception, that's on you as the programmer to be careful. Unfortunately, because there's this Bjarne Stroustrup, the creator of C++ language, has this thing he likes to say. He said, "Being careful doesn't scale." Right? So you write a big program, you're gonna have some null pointer exceptions. You're gonna have some array index out of bounds exceptions. You're gonna miss stuff. That's just the way life is. Humans are fallible. So is AI. But maybe that will change. Who knows? All right. Yes.
so so like the try and catch stuff how does that so I understand for like the try stuff like you put the code in there, but like I'm still like a little bit confused about how it works.
Okay, so the question is, someone is still a little confused about how the try and the catch works. So the notion is, if I look at this code here on line 17, right, I've declared an array of size 3. On line 18, I'm attempting to index element 4. Now this is invalid. And what will happen is from this line of code, an array index out of bounds exception will be generated. That will kill my code unless I catch that exception. In this case, I catch array index out of bounds exception and I print it out. So nothing happens, right? And I should catch them like in the order that of subclasses, right? I shouldn't try to catch exception first because exception will catch everything. And but array, so the way this code is written up is if it's an array index out of bounds exception that gets thrown, I'll catch it here. If it's anything else, I'll catch it here. And then there's one more thing you really need to know or be reminded of, hopefully, is the way it really goes. Okay, well, there's a couple things. I take it back. So you can throw your own exception if you want. You can say throw new exception and you can give it a string. Usually throwing the base class exception is kind of bad. You would probably want to subclass it in some way, make your own kind of exception, allow people to catch your thing specifically. But you can throw any exception. And there's also a finally clause. The finally clause always happens whether the exception is caught or not. And I think that's all the basic examples. Okay, my computer seems to have locked up on me. What is going on? All right. Yes, Logan.
I have a question about a specific quiz.
Okay.
It's about acceptance. So, it's never the question.
Okay. Before I get to that quiz, just let me just point out, you can say class extends, and then you can say exception, or you can say runtime exception, whatever you like. All right. So this is quiz.
Quiz 7, trust 16. Well, I have to find the type.
Okay, quiz 7. Let's go to quiz 7 and just describe the question to me. Which one is it?
It's the exception one. It's like the last one.
All right, let's go down there. Okay, so yeah, this is variants of this one are ones that I like to do a lot. Okay, so so is line 0 in this case going to throw an exception? No, it shouldn't because it's in bounds, right? And it's not null. And then so this line should print, right? So this line should just execute and it should be fine. And this line should execute and it should be fine. If A is greater than B, throw new error. Okay, so let's go back and figure out what's going on with A and B. A is initialized to 3 and B is initialized to 4. And then B is updated to 2, right? So is A greater than B? Yes, A is greater than B. So it's going to throw an error at this line. And exception is error a subclass of exception? Anybody? No, it is not. So this will not catch. The finally will happen though. And that's that. Make sense, Logan? Good. Yes, B something. Brad.
For the last line that's after a finally.
Yep.
In terms if that runs or not. Like if you have a.
The only way this line can run is if it got caught.
Okay.
If it didn't get caught, then the line after it can't run.
So you don't even have a catch call. You have just like a try and a finally.
Right. Finally will still run.
And then the thing after that
Will not run. It can only run. The only way that you can get past the try catch block is if you catch something.
Line 4, that would be frozen exception.
Yes, line 4 would be throws exception. That's exactly what it's doing, throwing new error. Next question. Yes, Vanik.
Could you go back to example 3 of the try catch?
Example 3 of the try catches. Yes.
What would happen if you would reverse the order of the catch statements?
I believe it won't compile. Hold on. I messed up my indentation somehow. I guess it's that. Yeah, okay. Array index out of bounds exception has already been caught, is what it says. So when I caught exception, that includes array index out of bounds exception. So the compiler rejects it.
And then accepted because array index out of bounds
Is a subclass of exception. Yes.
It goes through the exception and then it goes afterwards to the other catch thing, or does it like?
Well, it's going to go one of the catches. So you should think of in a way, a catch is kind of like an else if, right? So the first catch, if the first catch works, that's the one that works. If it doesn't work, then they go to the next catch. If that catch works, that's the one that works. So it's just like if else, right? Until one of them works, it keeps going. And then once it finds it, that's the one it does. Next question. Yes, Olivia. My linked list. All right. Okay. So what we have there in the head, in the top of that, is we were attempting to make a pop method and a push method, and we commented out kind of an awkward one. And we first tried to put it at the end, and that didn't work out because we wound up having to do an order n operation. So then we went to this thing where we put it at the beginning. So that's just a reminder of what that is. My linked list is based on a series of links. And the way you do a link is you have an object which holds your data, and then a link that's next. So link, this field is the same type as the declaring class, as the class it's in. And that means it's a reference to its same type. And you can build a chain of these references to form a linked list. The way I have chosen to write this linked list is I keep track of a head and a tail as well as a size. So I initialize it. I mean, putting size equal to 0 is redundant because that's the default value, but sometimes it's nice to document things, you know, for clarity. Okay, so if I want to do a get method, right? If I want to do a random access of a MyLinks list, then what I need to do is I need to search through the list until I find the nth element, because I can't just look it up in the table the way I can with an array. So I start with a counter. I say for int counter equals 0, counter less than n, counter plus plus, and then there's this line x equal x dot next. That's what causes x to move through the list, right? And a set works the same way. It's just what I do at the end. So in the get, I return the data. In the set, I update the data. And for a clear method, I can just set the head and tail to null and the size to 0. And the Java garbage collector will clean up the memory for me. The insert method is a little more complex. Do you want to walk through the insert method, Olivia? She does. Okay. All right. So what we're going to do with the insert method is we're going to take a position that we want to do the insert, and then we're having an object that we want to insert. So the idea is object O should be at position pos after this operation. So I'm going to create and instantiate a link reference with the object. And then I'm going to create another link reference named X, and I'm going to initialize it with the value of head. And now I'm going to do that same thing that I did before, except I'm going to go to counter pos -1. I want to go one before the place where I want to insert this element. And I'm going to just move the X's forward till I get there. Now, if the list is empty, right, I'm going to do, if the list is empty, head is null. I'm going to say head equal tail equal link. And that's, you know, if I get to this path of the code, then pos had better have been 0. Because if it's not, you know, I'll probably get a null pointer exception before this point. Anyway, this is a graphical depiction of inserting C. Now, I'm imagining a list that looks like A, B, D, E, where the arrows here represent the next fields on the link class. And the H represents the head, the P represents pos up here, and T represents tail. Okay, so this pos is going to be initially 2. This X is going to point to B. And what I want to do is I want to update this linked list so it's A, B, C, D, E. So I'm going to say link.next equal x.next. So link is currently pointing link is the thing I've allocated, and it's currently got a C in it. So I'm going to take its next field, and its next field should point to D. And since X is currently pointing to B, that means x.next fields is pointing to D. So this updates the next field of the link I'm inserting with the one that should follow it. Now I need to update the link that's in B so that it points to my new link object. And so x.next equal link, and that does it. And the final thing that I need to check is if the next link is null, then the tail gets updated. So if I'm inserting at the very end of the link, I have to be careful to update the tail pointer. And then I should increment the size of the array because I've just added 1 to its size. Finally, I put an assert statement in where I say get pos dot equals O, which verifies that the element at pos is now O. Any questions? Yes, Michael.
I'm just confused on like the link.next equals x.next. I feel like, I don't know, my brain just keeps like it's like
Okay, so x is pointing to B, right? So where's B dot next pointing to? D, right? And so link is got what piece of data in it? Yeah, what letter? C, yes. Okay, so I want the thing that's next for B to be become the next for C, right? Because I want to put this in between here. So I need C to point to D, and then I need B to point to C. And so the way I make C point to D is by setting its next pointer, because that's what that little graphic means. I'm setting the next pointer of C to point to the next pointer of B. All right.
I was confused on where, like, what the value of
Link is, yeah, link is at the top here, right? I instantiated link with the object. So this last thing that's in the assert thing, it's great for knowing correctness of my code, but get is an order n operation. So, and insert, if I don't do that, insert is still an order n operation because I have to do this up here. So I guess it's not as terrible as I was thinking. Does that explain linked list for you, Olivia, or should I keep going? Keep going. All right. Here's the add method. The add method is really a special case of insert, right? I'm inserting at the end, but I can make it a little simpler for the purpose of your brain. So I'm going to increment the size. I'm going to create the link object that points to O. And then I'm going to, if the head is equal to null, then I'm going to set head tail equal link. Otherwise, I'm going to do this picture here. So I have ABC, right? And I'm going to introduce D. So I'm going to take C, all right, the C has got its next link is currently null. I'm going to make it point to link, the new data that I've built. And now I have this picture, which is the correct thing with the thing added to the list, except the tail pointer is wrong. So now I'm going to update the tail pointer to point to link, and I've done an add, right? So it's really a special case of insert, but it's a little simpler to read. Any questions? All right. Compute size. So I just have this method here, so I can validate that I'm keeping track of size correctly. And the notion is, I start with the link at the head, and I continue until the X is null. I increment count, and then if X.next is equal to null, then I assert that the tail is equal to X, and I do an X equal X.next, and then I return the count. So this is all just, the compute size is all about, just making sure I did things right. It's for testing. But in reality, I don't want to ever call it in a deployed application, because it's just a performance hit. The size method, I have an assertion that size is equal to compute size, but really, if I'm not running with assertions, I can just return size, because that's what's supposed to be there. Adding things at the front is really easy. So prepend, okay, what I do is I say link temp equals new link. If the head is equal to null, then the head is equal to this temp thing here. Then the tail is equal to this temp here. And then otherwise the head is equal to temp. And I size plus plus. Now I skipped over one thing. The constructor here took the object and the head pointer. So this is going to update both the data and the next field in the constructor. So the prepend method is like practically the simplest thing ever. And then I just have a main method where I just test things out. And after the main method, I have an iterator method. Now, the iterator method comes from the iterable class, right? And the iterator method enables me to use the enhanced for loop. So the way I did this is I started before the head. So I created this pointer cur with a link to the head and another one called prev, which I initialized to null. And my has next method is cur.next not equal null. My next method is previous equals cur equals cur.next, return cur.data. And the only reason I kept prev around is because I chose this time to implement a remove method, which I don't think I've done for anything else, but it's something that you can do. And in this case, what I did is I said, if the current is equal to the head, then the head is equal to current.next. So if I'm eliminating the first thing, in the list, that's very easy. I just update the head to point to the next thing. Otherwise, what I need to do is I need to have it, something like ABC where the current is B, and then I need to say the previous dot next is equal to the current dot next. And that's the way I update the current. I mean, I remove the current thing from the linked list. All right. The last thing I have in this method, I think it's the last thing. Yeah, it's the last thing, is a toString method. And I had a couple of different ways of doing it. But what I settled on was I said link x equal head while x does not equal null, sb.append x.data. If x, and then x equal x dot next. And if x is not equal to null, append a comma, and then append a square bracket. At the top, I appended a square bracket also. Yep, there it is, string buffer and new square bracket. And that covers everything, how everything works in the my linked list class. Does that help you, Olivia? Good. All right. Who's got the next question for me? Oh, it's 10 o'clock. Time for the quiz. All right, so next class will also be a review. So we'll keep the fun rolling.
Can you like send everybody all the previous?
Yeah, I can do that.
Yes, please.
All right.
And this one